Welcome to the project demonstration of grid monitoring and controlling through the MATLAB GUI using ZigBee technology. So from the MATLAB GUI graphical user interface, we are going to monitor the parameters of the grid. So this is the grid section we are representing, and from here we are going to monitor the four parameters. So that is the voltage, current, temperature and frequency from the grid which we are going to distribute that. So the temperature is by using this LM35 temperature sensor, and the next voltage and current from these two potentiometers. So this is the current potentiometer and this is the voltage potentiometer. And why? Because in real time we are going to use the CT and PT, current transformer and potential transformer. So here we are going to we need to change the current and voltage. So that's why we are using the potentiometers to change the values. And the next, for frequency counter purpose, we are using optocoupler, that is PC817. So inside this PC817 there is a LED and phototransistor. So whenever we are providing the AC signal to that, which is from this transformer, same 12 volts AC to that, so there is a LED will getting on and off. So the same LED on and off will be given as light input to the phototransistor, which is on the other side of this other two pins, nothing but other side two pins of this PC817 optocoupler. So from there the microcontroller will get the pulse inputs. So that was input to the timer pin A4. So microcontroller will measure the counts per second. So nothing but frequency of the input AC signal. So in that way we are going to measuring the AC signal with the help of the timer inside the microcontroller. So remaining temperature sensor and voltage sensing changes potentiometer and current are interfaced to the respectively A0, A1, A2 pins of our microcontroller. So based on this, the data will be sent to the MATLAB GUI based on the request. From here when we run the MATLAB code, so one GUI, graphical user interface, will be developed and will be shown for the user interface. And when we touch on the read icon, then we'll get the live readings. And if you want to control the devices, for example, this bulb will show the status of the circuit breaker, and if you want to getting on and off. And next, if the temperature is high, then with the help of this cooling fan we need to control the temperature. So that two device control will be done from the MATLAB, and the commands will be read by the MATLAB and given as input to this ZigBee module, and from there to the PL2303 is a module. So there's a USB to TTL converter module, and from there the data is received by this here ZigBee module, and from here to the microcontroller at B0 B1 pin. So from there we are going to control these two devices which you are interfaced at C2 and C3 pins. So here the power flow is 230 volts AC input to the transformer, so which will step down the 230 volts AC to 12 volts AC, and parallelly that was given input to this load through this electromagnetic relay. And after that the 12 volts AC input to this regulated power supply board. From here we can see parallelly that is input to the frequency counter as we discussed initially, and the next is input to the RPS, regulated power supply board. So that is the rectifier section. These four diodes will act as a bridge rectifier which will convert the AC to pulsating DC, and the pulses will be removed from this capacitor which will act as a filter here. And we need 5 volts because our operating voltage for the microcontroller and the ZigBee and relay and fan are the 5 volts. That's why we are using a 7805 regulator. So from there the output is 5 volts, which is the main operating voltage to our motherboard. Before on the kit we need to install some applications. The very first application is MATLAB. So after installation this MATLAB, then another application we need to install, that is PL230. So in this one project folder which we provided the code and MATLAB application. This is a MATLAB application. So to install that, follow the steps which are mentioned in this readme. And after installation the MATLAB, then we need to install the PL2303, so the application for this module. So after installation, at the end it will ask for to insert this PL2303 module at the end. So let me show you again better. Right. So when it asks, because already it was installed, so let us go with ignore. Right. So as we discussed, it will ask for the inserting. So insert that to any USB slot. So right, so actually we accidentally restart the laptop. You're not supposed to press restart. So go to restart later, and after inserting that USB TTL into laptop, right click on this PC and go to show more options and go to manage, and then go to device manager. So device manager, there we get the ports here. So here are the ports. So here we say the COM5. If it is updated automatically, so then it will show the instead of showing the COM5, it will show you that contact the seller or contact the developer. Then if you show like error, instead of showing the COM number, go to update driver, browse my computer for drivers. Let me pick from here. So here it will show you the two numbers. One is the 2008 version, and there is a 2022 or 2021 version. So we need to select 2008 version and then next, and it will install the driver, and later you can see the COM number here, right? Okay, if you get the error, otherwise just leave it here. So we got the COM5 now. So after showing the COM5, go to our MATLAB. Sorry, it's a MATLAB 2009, right? So go to the MATLAB code. So this is the code which we are going to use. So open that in our MATLAB 2018 version. So that for that go to C, program files, MATLAB, that is 2018, right? So in that bin file, there will get the matlab.exe. Okay. So now our 2018 MATLAB version will be, because this code will work without any error in 2018 version only, as it required some MATLAB functions which are developed after 2018. So we need to use 2018 or above version. So right, so after MATLAB got open, then go to open file, go to open, and go to the project folder, and then serial data annotation with the GUI home, open the code. So this is our code now. So here just no need to change anything, better to keep this as a master copy aside. So then run the code. Change folder. Before run that, give the power supply to this project. So when it is on successfully, the two lights will get switched on, and you can see one blue light is blinking on this module, right? So it's blinking, nothing much. We are receiving the data from the kit. Change folder. Now run the code. So we got this GUI right now. Okay. And so if I want to read the data of the sensors, so I click on the read data. There we will get the data from the kit, so which will display an annotation of voltage, current, temperature and frequency. So right, so we got this annotation, that is a figure 1. So voltage, current, temperature and frequency. So here if you want to change the values, consider, so there we need to change the values. So now let us see that I want to change the current. This is the current parameter. Okay, so I want to decrease that. So anti-clockwise rotation, decreasing. So when you want to read the data again, so you can check that the current is 0 now, right? So if I increase that, so manually we need to check the values. So clockwise rotation, I increase that. So read the data. Now the current is more. So if I want to control the circuit breakers, then device 1 for circuit breaker relay for the bulb. So I'm controlling that. So right. So if the temperature increases, so we can see that we are providing some heating to the temperature sensor. So when you click on the read data here, so we'll get the live data also, right? Temperature is 48. So if you want to control the cooling fan, then just device 2 on. So it will on the fan. So after everything was normal, so device off and device 2 also off. So right, fan also got switched off.